So we got this situation to handle. So if you'll observe this question, you have to find out limit of something which is given in form of sum. So can I say that it is limit of a sum? So first we will write down this question into a correct pattern. So limit n tends to infinity n by n square plus 1 square plus n by n square plus 2 square plus n by n square plus 3 square, and then dot dot dot. Last term will also have n square n on the numerator. So what I will do, I'll multiply and divide by n square. So on the numerator, I'll multiply and divide by n. So the denominator will become 5n square. So what I will do, I will write n square, and then I have to write 4n square, but we have to write down that thing is complete square. So what I will do, I will write 2n ka whole square. Okay. So this is my idea to write down this question. Now we are good to apply the limit. So look at here. So can I write summation? This is n by n square plus r square. R starts from 1 to 2n. This is my idea to write down this question into the given form. Now, you know that while handling limit of a sum, we used to replace sum with integration sign. We used to replace r by n with x. We used to replace 1 by n with dx. So this is our idea to handle these kind of situations. For that we have to create r by n. So what I will do, from the denominator we will be taking n square common. Okay. Now look at here. So can I write r starts from 1 to 2n, and then we will be having n. If I will be taking n square common, we will be left with 1 plus r by n whole square, and 1n will be neutralized. Now you can apply the replacements. So if you'll observe, you know that you have to replace your summation with the integration sign, and then you have to replace r by n as x. So if r is 1, so if r is 1, you are left with 1 by n. Now you know that n is approaching infinity, so 1 by n will approach 0. Okay. Now r is what? Now for upper limit, you know that upper limit is 2n, so you have to write 2n by n. So n gone, you are left with 2. So this is done. Now you have 1 by n, so you have to replace it by dx, and then 1 plus x square. I hope you are comfortable at this stage. Okay. Now my idea is that we have to do the definite integration of the given situation. Now, do you remember the integration of dx by 1 plus x square? It reminds you of what? Tan inverse x. Correct. So it is tan inverse x. Now you have to apply the limit. So it is tan inverse 2. Okay. Tan inverse 2 minus tan inverse 0. Tan inverse 0 is nothing but 0. Therefore, the required value for this question is tan inverse 2. I hope the idea is clear and you guys can handle similar situations.